Any questions? Like for the remaining minutes, you can just ask open discussion round. Yes.
So if we decided to, like go further into like reinforcement learning, but again, like assuming that we are, at least speaking for myself, I'm very new to this. Is there a good reason not to go for Keras as a starter?
No, you can go for Keras. Yeah. But if you do Keras, you don't really see or learn what's behind it.
Right.
It gives you a wrapper for the whole. Like there's a DPD, like deep deterministic policy gradient, DDPG. There's a wrapper. You just say Keras DDPG, and then you say whatever the neural network architecture, and it's done. You don't have to worry about anything. Right. And no one is preventing you of doing this. Mm-hmm. And the way I see Keras and the way I see like PyTorch is this. If you want to do extreme prototyping, you just want to move as fast as you can do everything in Keras. Things can go very fast. But if things don't work, and for you it's just like a black box, right? It's going to be harder to optimize, harder to understand why is it not working and to improve. So if you have an idea and a feeling what you can do and what you cannot do, and this takes experience, it takes some time. It can take you considerably much further than just knowing, oh, there's this Keras black box I can call it.
We can do like some sort of like soft introduction, I guess. The Keras way.
I wouldn't say the Keras way can be used for introduction. So the Keras, if you code it, the algorithm, if I code the DPD, say any deep Q learning, and code it in Keras and in PyTorch, like more than just, oh, here's the black box you can call. Like I show you the algorithm, the code behind the algorithm, even in Keras, it's almost identical to PyTorch. Yeah. It's like you want, like most of the code from say previous session was a lot of code. It was like mostly coding, but the deep learning code, like the deep neural network stuff, was like very minimal. It's like all the other thing around it, and this is like very independent from TensorFlow or Keras or PyTorch or what have you.
So what would you suggest for further improvement, like from now on? Should we write
I think
our own code from the scratch every time we want to implement something? Right.
I think it depends what you want to do. I think you should at least try to implement some in PyTorch, and once you are familiar and you feel like confident with them, you can start do it in Keras or whatever.
I think it depends what you want to do, right? So if you're learning let's say reinforcement learning itself, you don't want to care about the like new training problem, then you just take it as a black box and you're sure it's not right. But if you are really caring about the details of how it's trained, then you need to run over yourself to understand that. But in my experience, I think like using Keras sometimes it's good because you don't have the problems like debugging all the stuff behind that, and then you're faster, and then I don't know, you learn more probably. But at some point you hit the limit, and then you can't use Keras anymore because like some new stuff you want to implement, you need to go directly to TensorFlow or Piano or whatever, then do it from scratch. That's kind of what happened to me last week. So it has standard stuff, but beyond standard, you need to implement it yourself.
So Keras has lambda layers, and I once did something in the lambdas layer, but it's not very easy to do, very comfortable to do. And there was one person, I think Serena posted in the chat, she had a problem how to make a custom loss function in Keras. And I wanted to say, oh yeah, I've done it 1 year ago, but I completely forgot how I did it. And it's like, it's also not super pleasant to do. And it's actually super easy to do in PyTorch. So everything has its advantages and disadvantages. If you want to just take things out of the box as they are and just play a little bit around with the architecture of the neural network, you just go with Keras and knock yourself out. If you want to do some more custom things, then you kind of have to go with PyTorch.
It's funny, like when you do standard stuff, I think you end up writing Keras. If you work with Piano, and if you want to repeat this thing, right, it's not efficient to code it every time. So you make a class, and you end up, okay, I already implemented something like Keras. So why am I not using Keras?
Yeah. Well, I was not a big fan from TensorFlow when it came out. I didn't like it from the very beginning because it had a lot of boilerplate code.
Yeah.
Like you had to always initialize your own variables, and I felt like it was like done on purpose, like to make it not very easy to like.
For sure by design, right? They want to separate the graph from the run.
TensorFlow
For
2.
sure by design.
Yeah, but TensorFlow 2 is
I
like.
don't think the design was to make it harder to do.
I don't think so.
But I think the design was because it was engineering focused and optimal. And when you make something engineering optimal, it loses its readability, right? So that will happen. They tried to fix it with TensorFlow 2. I don't see too much of an improvement. There are some improvements, but they also added now parallel templates as to how to create neural nets that I think are just unnecessary. So just 3 boilerplates do the same thing. With Keras, I do agree with Florian. I think if you're just running something, you want to do it quickly, definitely do Keras. But if you want to get in depth in your algorithm, definitely don't do Keras, because then customizing the cost function or anything else is just a headache.
I think once you're set up all with the Keras, then with the Lambda layer, I think you're gonna be fine, unless you want to do something really crazy. You want to change something really fundamental.
I think like the way they implement back propagation in TensorFlow is really good. They do like reverse mode auto differentiation. It's really nice. So I think it's very helpful to know these things in order to get a deeper appreciation of subject.
No, but debugging still is such a mess in TensorFlow.
Yeah.
And you don't really, you read it, you're not going to understand what it means, because it's referring to libraries that you're not really, like you didn't code, right?
Sure.
So it's much easier to debug a PyTorch code rather than Keras or TensorFlow, right?
Absolutely.
And the thing with Keras, I mean, just use it, but like customizing a cost, like just writing a custom cost function is a ordinary day-to-day job for anyone who's actually practicing deep learning, and that is just much easier with PyTorch. Last thing, if you want to create some layers very quickly, you can use all these layers in PyTorch and TensorFlow too without having to use Keras. So I would say Keras just for rapid prototyping. You have architecture, you have very standard things, do it right away. Otherwise, definitely do PyTorch.
Yeah.
I want to ask a slightly different question. So, when you actually, not like for us with learning, but in the real world, when you implement reinforcement learning, where do you spend most of your time? Like, what is the difficulty? Is it in?
I think it's just to understand why it's not working. I would say, like, it's very hard to generate.
Do you try like just different, like learning algorithms? You try like in the environment itself. Like, where's the?
I think you just have to do it like iteratively. You say, okay, this is not working. You understand why it's not working, and then you do some fix what you think makes it better. Like say you change it, is you say, okay, the learner and the model is learning some behavior I don't want it to learn. Then you just have to tweak the error for the reward function that it doesn't reward this type of behavior, and so on and so on. Like you say, okay, the learner should be able to learn this. Maybe I need a different neural network architecture, or whatnot. Like problem is always like generating the training data. This is like a big problem, but there's nothing you can do for it or against it.
I guess the point is complicated. There isn't many evaluation metrics to truly understand how good it is, right?
I think OpenAI just recently published like a benchmark for evaluating these models, which is reinforcement learning. I think it was published in the chat. I have to look it up again. So you can take a look at this. There's like 7 criteria to evaluate your reinforcement learning algorithm. But yeah, that's the problem. There's no real benchmark.
It's easier to test the performance on simulations, but once you get a real world problem, it's just a hell.
I think it depends, right? Ideally, you want to learn with simulations, but then you struggle how much is your simulation descriptive of the real world problem. Right.
So we have 4 minutes. Do you want to wrap up?
So my closing speech.
You do your closing
I haven't
speech.
prepared anything. So
What's the future?
the future of RL?
Yeah.
Good question. I guess
So I think the future is RF.
we have to.
Funny part.
I hope you
Maybe
had your
optimistic.
fun with the course. I hope you learned something you can take away home. We have lots of code which you can go through by yourself. If you have any questions, you can post them in the chat. Do your breakout session. So stay there on top. If you like, I gave you a push now, like to into the right direction. But if you go home and you don't invest additional time in the material and into the problem and into the code, then I guarantee you in 2 months you will forget everything we talked about. So you have to keep on doing it and kind of doing this kind of breakout session where you kind of try to recreate or you write a review about the paper. It's definitely good for you just to keep on track and keep doing things.
Do you mind doing the survey now, please?
Can you also say it so that online people do?
Online people, can you please do the survey now? It was just posted in the everyone chat. Please do the survey.
After you watch the offline video.
All right, awesome.
I guess
That's
that's
it.
it.
Thank you.